When discussing the capital asset pricing model and the security market line, we need to keep three things in mind. One, there is a basic reward for waiting, the risk-free rate. Two, that the greater the risk, the greater the expected reward. And three, there is a consistent trade-off between risk and reward. Now, the security market line is shown in the graph on page 234. Now, up the vertical axis are the expected returns. And at the intersection between the y-axis and the security market line, we have the risk-free rate. Okay, and then across on the x-axis, we have the betas, or the measure of risk. And this is the security market line. Okay. Now, the security market line is a linear equation, and it reflects that as the beta increases, or the risk increases on the graph, so does the expected return, because as we move to the right, the beta is getting higher. The level of risk is getting higher. So it makes perfect sense, considering what we've studied so far, that if you are going to assume more risk in an investment, you want to be paid more. So since the security market line is a linear equation, the typical formula is y equals a plus b times x. So let's define the equation by the variables we will use. Okay, so y is equal to the expected return at some investment level. Okay, then we have a is equal to our risk-free rate. Then we have our b, and that is our expected return from the market. Okay, and that is, you subtract that from the risk-free rate, and that's going to give you the market. That's going to give you the market risk premium. Sorry about that. Let's make sure we have that straight. The b in this equation is the expected return from the market minus the risk-free rate. That is what the b stands for, and it's referred to as the market risk premium. Then we have the x, which is going to be the beta, or the measure of risk. Now we can write the equation for the SML using our new variables. Okay, so I'm going to rewrite it here just so we can keep everything lined up. Okay, this was the original equation we were working with, and we are going to rewrite this. So our y is equal to ERI, our a is equal to the risk-free rate, our b is equal to the expected return from the market minus the risk-free rate. Okay, that's our y and our b, and then our x, we've got to add that, is our beta. All right, so if you look on page 234, that is exactly, if you look at the bottom of page 234, that's exactly how we have converted this formula over. Okay, 234 at the bottom of the page, the beta of the investment. Okay. All right, so we can build up the security market line from analyzing two risky investments. Now, the slope of this line, which you would have learned in your math classes, is the change in y divided by the change in x, and that is your slope. Now, once we calculate the slope, we can find the intercept of the line using the linear equation, which we just wrote here. Okay, so now we have the slope, or the security market line, and the expected return. And if we plug that information into the linear equation, then we can solve for the risk-free rate. Okay, and then the formula for the risk-free rate is equal to the market risk premium minus the expected return. Okay, so we've pretty much gone over the basic explanation in general of the capital asset pricing model. Okay, now let's look at example 8.5 and calculate the expected return of these two companies. Now what I'm going to do immediately is put our formula back at the top of the page, because we know we're going to be referring back to that. Okay. Now in this problem, let's write down everything that we know about in this problem. Okay. If Portland General Electric has a beta of 0.75, which is the level of risk given the investment, and Ford Motor Company has a beta of 1.2, what is the expected return of these two companies if the current market risk premium, the slope of the security market line, is 10%. Now keep in mind that this is also the current market risk premium. And the current risk-free rate is 3%. Okay, so sounds like it's gonna be pretty complicated, but it's really pretty straightforward. Okay, the first step is to write out the SML equation, the security market line equation form, with the information that we know. Okay, so we have the formula right here. So let's do this first for Portland General Electric. Okay, so we're looking for the risk-free rate, which is 0.03. That was given in the problem. Okay, we know that this part of the equation right here is the slope. Okay, so we really don't have to calculate this. This was given in the problem as the current market risk premium. Okay, so we can go ahead and even, if it helps keep us straight on this, current market risk premium. Okay, so we know that that is 0.10. So we're going to take our risk-free premium, we're going to add 0.10, and then we're going to multiply it by our beta for Portland General Electric, because that's who we're dealing with right now, at 0.75. And then when we multiply all of this through, we get 10.5%. Okay, and that's our level. This is our expected return given the level of risk. Okay, so then let's do our beta for Ford. Or I'm sorry, not our beta. We're doing expected return. Okay, so let's get this. All right, so same thing. We have our risk-free rate of 0.03. And then we have our current market premium. That's not going to change. The only thing that's changing between these two companies is the beta. And that is 1.2 for Ford. And then when we calculate all this out, that's where we get our 15%. So this gives us the expected return from Portland Electric. We can expect a return of 10.5%, and from Ford an expected return of 15.0%. So you can actually make your decision on expected return based on the level of risk that you will be taking. So obviously if you're looking for a higher return, you would go with the 15%. That would be the level of return that you would want to get based upon a beta of 1.2. And if you're going to invest in Portland General Electric, then you would expect a return of 10.5% given a beta of 0.75. So if you have any questions, let me know. And you can post your questions to the discussion board as well.